All right, 4.7, we're getting into graphing. Graphing quadratic functions into intercept form. All right, so intercept form is f of x or y or 0, they're all interchangeable, equals a times x minus p times x minus q. For example, 2x minus 3x plus 1. Now, we've already done this before where we've solved and set these equal to 0. And we get 3 and negative 1. And we said that 3 and negative 1 were the x-intercepts. They were the solutions. They were the roots. All the same thing. Okay? So the shape of a quadratic is a parabola. Something like this. Something like this. If it opens up, it's positive. A little smiley face, happy. And if it goes down, it's negative, into a frown. A parabola has an axis of symmetry that reflects the left and the right side of the graph. So when you have a parabola like so, the axis of symmetry goes through the vertex, the lowest or highest point, and if you folded it, it would match up left and right side. All right? And the intercepts are at p comma 0 and q comma 0, which we talked about up the top. So, how do you do this? You find and plot the two x-intercepts. You find the axis of symmetry. And you find the vertex. Then you find one more x value to make it into a coordinate point. So, for example, we have 2 times x minus 3x plus 1. So we set them both equal to 0. We said we're going to have 3 and negative 1. All right? So those are the two matching points. Remember, the axis of symmetry is halfway in between those two. Okay? So if we add them together and divide by 2, we'll get where the axis of symmetry is. So 3 minus 1 is 2. 2 divided by 2 is 1. That means the axis of symmetry is right here through x equals 1. Now think about it. 3 is 2 spaces away from 1, and negative 1 is also 2 spaces away from 1. All right? Now, since we know x equals 1, the vertex is somewhere on that line. That means the vertex is at 1 comma something. So if we just plug a 1 in here and solve, we'll find out what that is. So 1 minus 3 is negative 2. So we have 2 times negative 2. 1 plus 1 is 2. So 2 times 2 times 2 is 8, and that's going to be negative 8. So the vertex is at 1, negative 8. Now, since my 2 out here in front is positive, that means it's going to be a happy one. So it's going to go up. We already said our x-intercepts are at 3 and negative 1. You can also write 3, comma 0, negative 1, comma 0. Either way is fine. The axis of symmetry goes through the point 1. All right. Now let's look at our calculator. If we go to y equals and clear out whatever's in there, and we put 2 parentheses, okay, remember it's x minus 3, and x minus 1, x plus 1. All right, and we hit graph. Okay, and we hit second graph, we'll get the table. And look, here is our vertex right there at 1, negative 8. Here are our two roots, negative 1, 0, and 3, 0. And then we can get other points like negative 2 and 4, 10. So negative 2, 10, and 4, 10. And that gives us enough dots to make a decently shaped parabola. Now the domain, remember, domain is left and right. So it's going to keep going left, and it's going to keep going right forever. The range is down here. How low does it go? Well, it goes down and includes 8. And it goes up to positive infinity. All right? Let's try this again. Now notice, when I see this negative out here, that means it's going to open down. My roots are going to be at 4 and negative 2. My vertex, 4 plus negative 2 divided by 2, is going to be also at 1. Okay, so that's at x symmetry is x equals 1. So the vertex is going to be 1 comma something. I can plug it in, but again, I want you to use your calculator, so let it do the heavy lifting for you. So we're going to change this and put a little gray negative key there, and then parentheses x minus 4, parentheses again, x plus 2, parentheses, graph. It's opening down. Let's see where that vertex is. 1 comma something. 1 comma 9. Right there. Okay. And then back to there. Get some other points. How about 0, 8, and 2, 8? And right there, I have enough to get a decent idea of what it looks like. Here's my parabola. So again, that was at 1, 9. The domain is still going left and right forever. Now this time the range, it's going down towards negative infinity. All right? And up to and hitting at 9. Bracket, because it touches it. All right? Same thing here. We have a negative out in front, so that means it's going to open down. My zeros, negative 2 and negative 6. All right, so negative 2, negative 6. Negative 2 plus negative 6 divided by 2. Well, that's negative 8 divided by 2, which is negative 4. So my vertex is going to be somewhere along that line. So negative 4 comma something. My axis of symmetry that I just drew in the dotted line is x equals negative 4. Always an x equals line. I can tell you right now, before we even graph it, it's going to be negative infinity to positive infinity. Because that's what parabolas do. So calculator. Y equals, clear out what we got. Negative 2, parentheses, x plus 2, parentheses, x plus 6. Graph. Looks about right. So we're going to look at negative 4, and that is going to be right there at 8. So negative 4, 8. And then just get some other points to make it better. So it looks like negative 6, 0, negative 2, 0. We already got those. How about negative 5, 6, and negative 3, 6? So negative 5, 6. And negative 3, 6, mirror images on either side of the axis of symmetry. And there we go. So this one again is going down to negative infinity forever and goes up and hits 8 with a bracket. Okay, convert into intercept form. In other words, we need to factor this. So I need two numbers that multiply, give me 63, that add to 16. Well, that's 9 and 7, both positive. Now, when I set those both equal to 0, I'm going to get negative 9 and negative 7. And I think you can tell without doing any math where the axis of symmetry is going to be. It's going to be at negative 8, right in between. Okay? A very thin parabola. Okay? So what do we got here? It is opening up because it's positive. My x-intercepts are -9 and -7. The vertex is going to be at -8 something. And the axis symmetry is x equals -8. I don't know why I just put a parentheses there. I was thinking of the vertex. The domain, we already know, is going to be this. All right? So, let's go to the calculator. Y equals clear. And I could put in either one, x squared plus 16x plus 63. Doesn't really matter. Or x plus 9 times x plus 7. Okay? So let me just show you. X squared plus 16x plus 63. Then go down here and do parentheses x plus 9, x plus 7. And when we graph, there it is. And there it is, because it's the same thing. Now, it kind of goes off the graph. So we're going to go to here and see -8. Got to go up a little bit. -8, -1, which we kind of saw from the graph. All right. And then -10 is going to be up at 3. And then it was going to be -6, 3. I didn't mean to say wide, narrow before. I meant to say it's kind of shallow. It just dips right below the line there. So there's your standard size parabola. Okay. Now, range. How low is it going? It's bottoming out at -1. It hits it, so there's a bracket, and it's going up in the sky forever to infinity. Convert into intercept form. So first off, we're going to factor out the GCF. Leave the -3, and then factor. I need two numbers that multiply by 5 that differ by 4. Well, that's 5 and 1. I want more negatives, so there we go. All right? And just for the heck of it, my intercepts would be 5 and -1. And real quick math, 5 minus 1 is 4 divided by 2. My axis symmetry would be at x equals 2. Didn't ask for that, but just for extra practice doesn't hurt. And that's it.